LeetCode Problem 572, subtree of another tree. So we are given two roots of two binary trees, the root and the subroot. And we have to return true if there is a subtree of root with the same structure and node values of subroot. And we have to return false otherwise. Right. So for example, here we have a subroot here, and in this big binary tree, we have to check whether or not in this big binary tree there is this subroot inside, which in this case there is 412. So what we have to do is we return true. Right, so for something like this, 412, and even though there is 412 here, but this 2 has a left node, which makes this subtree not the same as this subroot. Okay, so my solution requires a function from the same tree. It is another LeetCode problem. So what this function will do is to basically check whether or not given two roots of a tree, whether or not they are the same using depth search. Okay, so in this is subtree function that is for this problem. So we're gonna run through how the code works. So here I have a subtree. The subtree given the big root, right, is the big one, and then the subroot, the small one. Right. Okay, first we check whether or not the root is null. If it's null, we return false. Right. Since it is not null, so we don't do anything. Right. Okay, the first thing we do is to check whether or not this root is the same root as the subroot, which means that because it says here that the tree could also be considered as a subtree of itself, right? So if let's say the root is like this, and we're comparing it with this subroot as well, so in this case it will be considered as they are the same, and then we have to return true. Right? But for this example, they are not the same, which means this is not a subroot. So what we do is we recurse from the left. Okay, so it's sub3 recurse from the left. It's gonna be return left is equals to. Okay, so we go to the left node here. Alright, so now since we're here, when we compare this with this and its branches, basically this subtree and this root, they are the same from this function. Right? It gives us true, which means that this entire subtree is a tree of subroot. Right? They are the same. So what happens is this will return true, and then OR. Okay, so in this case it doesn't really matter because it is an OR, but if we were to look at the node over here, this will actually return us false, right? Because this subtree is not the same as the subroot given to us. So this will return false, right? And since this is true or false, we remove the left since we don't need it. So this true is from the left, this false is from the right. So we don't, since one of it is true, that means this will return true, which means, which is the same as the example given to us. Alright, another example, this one. Alright, so pretty much the same thing. We compare the root first, right? So if the root is the same, do something about it. So we traverse to the left node over here, right? And then we check whether or not they're the same. And in this case, since they are not the same, right? Since they're not the same, what we actually do is we traverse again, right? Using depth search. So it's still not the same, so we go back and then go to the right one, right? Because it's from the right. It is over here, the right side. Once we're done with the left side, we move on to the right side. And over here, we search. Okay, still not the same. We traverse here. We compare again. Still not the same. So we go back. Go back. Right. So in this case, both statement will return false. Right. Return false. We go back. Go back. Go back here, and then try over here. Please note, compare again. Still not the same. This will return false. So when we are at our root, it will be false or false, right? Because when we traverse in the left side, we did not find a subtree that is the same as the subroot, and when we traverse into the right side, we cannot find a subtree that is the same as subroot as well. So both of it is false, and then our function return false. Okay, because there's none of it is true basically. That's how a OR works. Okay, pretty straightforward. Hope I did my best to explain. That's all I have to show. Thanks.